Okay. I think most of you were here the previous days. You already saw a few times the DevOps Handbook. I helped also another book, the Web Operations book. It's also a good read if you want to do. It was mentioned that I did some DevOps days before. But I also organize mobile delivery days, which is continuous integration, continuous delivery for mobile development. So if you're a mobile developer, talk to me. Love to share ideas on that as well. Okay. The first day we did the exercise on dev and ops working together. And typically, you know, the first part is how can we deliver faster to production? It's typically, you know, the build system, the test system, and so on. And then there's a second area which is more like, can we do monitoring? Can we get the metrics? Can we get all information back? And then there's a third part, which is basically knowledge. So not technology, but you share the developers' knowledge into operations, because they write the application and the people running it, they don't know it, but you have to work together. For example, I think it was at Google, the first couple of weeks when a new app goes live, the developers have to be in the operational team and they will see what problems come. And then once you start seeing the things that fail, you talk back to maybe to the project team or the people doing the projects, what can we do better? So it maps a little bit on the first exercise, the exercise we did on the first day, this model. So the typical, you would have a technical loop and a business loop between the two things. So I just wanted to mention this model. We didn't address it in the first day, but it's another way of thinking how you can improve things. Maybe a little bit of background. The work that I do is for a television show, so we work with broadcasters. This is one of the examples where the children have an application and they can decide who is the next guest on the show. The kids will start voting. You will see the results, and then that person will come out of the door in the show. And we create not only the application, not only the real-time visualization in the studio, but also the management system, because maybe the guest, it's on Saturday the show, and the guest has to leave because his son plays football. So whatever the audience decides, it doesn't matter. We will just say who is the winner. So television, everything is fake. So this is a bit of the context where I work in. Okay, focus on the business. This is a little bit the stack that we use in our company. So we have, you know, Google, Trello board, Skype, everything is Office services. These are what I call community services, Ubuntu, can't even see what this is, but NPM from Node.js. Then we have a lot of backend services, like a CDN, like storage, Redis as a service, and then there's IT support services. Datadog, for example, is a monitoring service. We use a build service, a test service. Everything is a service. Also for the mobile thing, we have a lot of different services. So we almost have no servers ourselves. I know this is a bit strange for you here, but everything for us is a service. And the reason why we do that is that with our business is not building servers. Our business is not running a database. Our business is the broadcasting service. So we try to focus really hard on that, and then we let other people worry about all the other tools. But it's not always easy, as I will explain. So we use GitHub, but once in a while, GitHub is not available. And then we all drink coffee at the office, because we cannot do anything about it. We cannot go to a server and say, reboot the server. our build server all of a sudden decided to change their virtual machine. And we didn't know, but now all our builds are failing all of a sudden. Sometimes we run on Amazon, for example, DynamoDB or database system, and some requests work and some do not. But we cannot do anything about it. Maybe we find something in the documentation if we're lucky. Richard, remember your little sharing you did with me? The cloud, you know, the myth of the cloud, it will scale infinitely and as fast as you want. But when the people come for the television station and they say, please download the app, there is a spike of all the traffic. Well, guess what? The load balancer from Amazon is too slow for us. So we have to send an email to Amazon saying, please provide enough capacity because there is going to be a spike. And otherwise, it just will be too slow to start. So the nice thing is we don't have to maintain the systems ourselves. And we can work faster on the business domain. But the risk is going up. Because if something fails during the show, what do? We depend on all these services, and we cannot just call them. They're somewhere, you know, we have to create a ticket, and the show is only 1 hour. And by the time the ticket, somebody enters something in the ticket, the show is over. So we started thinking about how can we do the scaling of the system faster. How can we do these things? And there is a new trend called, sometimes called serverless. And the idea is, like in our case, we don't have to worry about the servers, and we just use the server, but we just use the service. Other people will call that function as a service. So what is happening here? So in the evolution, we are now seeing that we used to have virtual machines with the full operating system, you know, an Ubuntu running in VMware, running in Xen, doesn't matter, you had all the services. Then containers came along, and you could run everything in one container, but the idea is that you split off the functionality into multiple containers, because that you can like restart that only function very fast, like your authentication service, like your billing service. You split them up in different microservices. Function as a service even goes further. You deploy only one function. Only one function. It's not even the complete service. It's like one function that you deploy. And it is very equivalent to doing functional programming. Who has heard of functional programming? Okay. So, you know, you take the input and the output and you don't maintain any state. So run it once and then done. So imagine having a web server, like an Apache, to handle one request and then okay. So the nice thing of that would be that there's no memory leaks, because it's always a new state. It's much easier to think about when you work in that way. So this is an example where we used it for a show. The show was that people could put testimonials from their religion during a live religion show. And what they did is creating those images was typically, they say on TV, please share your testimonial, and then we would have like a huge peak of everybody filling in the testimonials. And typically this would cost us a lot because we have to anticipate all the servers for the whole peak load. And now we just did it with one function to get all the input, which is the text, maybe the theme they selected, and what was the output? The output was just saying, I create an image and I send the image back to the user. So it's one function that we just deployed like that. This is another one. This is for a kids application where they can create like their own animated GIFs, and they have like a drawing application. But the same thing is, there is input saying this picture goes in this coordinates, this picture goes here, this is the color, generate me the image, and this is the output image, or in this case, the animated GIF or the movie. So, how does that work? So, there are two ways of working with these systems. There is the synchronous way, which is I do a request and I immediately get the answer. Or there's the asynchronous way, where I say I send a trigger, but I don't care that much when the return calls come. And for example, the generate image would be one of those functions that we just deploy. It's a very specific thing, and we can deploy this function separately, and all the functions, the unit of deploy is only the function. It's not this application who has the whole API, it's just deployed at one function. So with serverless, with the trend came other things. Obviously, people think there's no worries about servers, so if you scale, let somebody else handle it. That's nice. The other thing is that I have a per request billing. So one API call, it's X amount of $cents. And for us, that's very interesting because we only have requests at peak, and after that, no requests. So if you only have to pay per request, that is a very good model for us. And also, similar to the peak capacity, at Amazon, we can say, oh, please provide us with 30,000 requests per second, and we do not have to pay extra. It could be 30,000 requests at the same time, and after that, nothing. So we only pay for 30,000 requests, and it's done. It's very nice in our model. But I think most of the people care about the function as a deploy. So you focus really hard on the one function, and then you can easily swap in, swap out new versions without having to go to a whole long cycle of build the container, deploy the container, and so on. So it goes much faster. And that speed for us is important because during the TV show, sometimes we have to, during peak, we have to deploy new functionality or fix functionality. So imagine otherwise it would take half an hour to run all our tests, do the whole suite, and then it would be too late. But now we can just say that function, update. An example would be that there was a jury for a TV show, like similar to So You Think You Can Dance. And when there was an audience jury and a professional jury, the producer on Slack asked us, well, let's say the jury had like 50% votes for him, and the community had like 60% votes for him. So the developer thought, okay, a percentage, it can never go above 100. And the producer thought, but if I put 55 on the television screen, people will get confused. So it would be better if I can say it's 50 plus 60 is 110. So we had to change the form that showed actually the correct number as the producer wanted it. So we had to do it live because he said, can you do it? Yes, we can. So this is a bit in general on serverless. I'm not going to go into technology details, but I found it really useful on how to reason about the dependencies of external services to look at promise theory. Promise theory is something that Mark Burgess, who also was one of the founding fathers of CF Engine, who created one of the first config management tools, thinks about how IT and applications work together. It's a bit too theoretic for me because it contains a lot of mathematics and stuff, which I do not understand. But I try to distill a little bit of the theory that you can see. So it begins with you are an agent and you work in an ecosystem of other agents. This could be, in my case, like I am an agent that provides the television service. And there are other agents in my system providing the database and so on. In your case, it could be maybe this is the department that provides the service of the firewall. This is the service that provides this service. So it doesn't have to always be in a SaaS model. You can think about your ecosystem now. Who do you collaborate with? Those are agents also in your system. And you make promises to other people in the system. We can do the deploy live. We will make sure it is running when the peak comes. Those are promises that we make. They should be able to check the promise, because we can say that, but if they cannot verify our promise, it's not really a promise. I can say, you know, I will do it, but the other one is still like scared. Are you able to do it? So whatever you promise as a service, others have to be able to verify that you can do it. So maybe you gain their trust by giving a demo. Maybe you kind of make specifications and show your test results or anything. Or in our case, what we did is because we run like 5 shows without success, with success, they believed us that we could do it. Depends on how you see it. The major difference is that we make a promise. It is not a contract. It is a promise. And it doesn't guarantee an outcome, which is very strange, because it used to be like, oh, if you do not deliver on your promise, you have to give me my money back. No. The idea of thinking is that we will all fail at some time. I'm going to do my best, but I cannot assume somebody else making a promise to me that he will always be there. So it's a different mindset of thinking about everything. So we used to build all these clusters and bigger clusters and bigger clusters, and they were designed never to fail. The new mindset is it will fail, and I've re-architectured my design. So if one fails, it's okay. If 2 fails, maybe it's also okay. So people using your service, they have to assume that you will be down. And if they start assuming that, life will be better. Because they have prepared for the worst, and it will not be the worst, and then they will say, oh, what do we need to do now? And they start pointing their fingers to each other. I can make a promise that I will keep up the load, but that's too generic. How much load? In the evening or in the morning? So when I make my promise to my customers, I have to put like conditions on there, because otherwise it will often be too wide. Because what if a hurricane comes? Or what if that? So I don't say you have to list all the conditions, but whenever you make a promise, in your head, you might have conditions that you think of them, but you have to kind of specify them to the people who are using them, because they, in their case, can see, oh, but for these conditions, that's not useful. I can promise the world and say, well, you know, it doesn't matter what load you give, we will scale. No, it doesn't work like that. So there's always kind of a little bit of conditions that you put in. And of course, you know, needs to be clearly documented if you want to make that promise very well. There's a lot of websites who just have the marketing thing and say, well, we can do everything, and happy faces on the slides. Part of you in the ecosystem, if you want to play in the ecosystem, you need to document what you promise and the conditions and everything. And the other thing is they have to agree. So the people using your service or you using the other service, you might be talking different things, like, hey, what's a user? We can support 10,000 users. What does that mean? Is that 10,000 requests? Is that 10,000 requests concurrently? Are those passive users? Are those active users? So all these kind of freedom in describing your product promise, you kind of have to sit down with your customer and say, well, this is really what I mean, and are you sure you understand what I mean? So documentation is pretty important, and agreeing on it. Like I said before, you might depend on other agents to keep your promises. So for us, it's all the external services that we depend on. And they will make promises to you. That's the ecosystem. And when they make a promise, I need to be able to verify it. I need to read their documentation, so it goes both ways. The important thing is, you cannot make promises on behalf of the other people. So when I say I will be up, but the other person says I will be up only half the time, I cannot say I will be up all the time. So I really have to know what their limits are and see what I can promise. They cannot be higher than the services that I use and what they promise. It would be very easy. I say, well, I don't pay for all the other services, and I take the risk, obviously, to say, well, I will be always up, and then I do not have a support contract and everything that. So it's important that you do not overpromise. It might seem the thing to do when you're starting a new business and you say, oh yes, we can do it. But always start with what you can promise and what the others are providing to you. And then maybe you can switch another agent or go to another agent and increase your service as you kind of can do more promises in there. In companies, internally, there can be conflicts on promises. Like maybe my colleague is running the mail server, and he promises that he will always, deliver your email, or there's a restore of the email service within an hour. Just an example. But I'm maybe in the network team, and I say, well, you know what? I can, if there's a firmware problem, I usually guarantee that there's enough bandwidth, but maybe another company is using the same network, and I cannot do the restore within an hour. He thinks he can promise that to restore in 1 hour, but because another customer is also using the same network, it will go slower. So sometimes, even within your company, there is a conflict of what you are promising to your customers. So by design, you can never have a conflict with another agent, because they promise what they can do, and you don't rely on that. The conflict can only come from your internal company. And the difference there is that if I want to keep my promise, I cannot force the promise on somebody else. I cannot say, well, you have to another service, you have to promise an uptime that is higher than me. I cannot force that. So it's always a pull from the dependencies you have. Okay, maybe I use this server, then I can guarantee a little bit more. If I use that service, I can guarantee a little bit more. But the others cannot push on me to keep my promise. And to have a choice, you have to eliminate the single points of failure. If you have a storage system, you create redundancy by adding multiple disks, maybe a hot spare, a RAID, whatever system, to create redundancy. But if I only have one service I depend on, and that goes down, what do? I created now a single point of failure by using their external service. Maybe internally they are redundant, but I don't see that. So for me, having only one service creates a single point of failure. Gonna skip that. Okay, coming back here. So you have multiple options. Let's say I use Amazon for storage, which is a service. I can think about, what if Amazon storage fails? Can I go to another provider for storage? That way, my single point of failure is solved. It might take half a day to switch. I put that into my conditions, that in case this supplier goes down, that you know what the condition is. But the things you gain by abstracting and using a service, you have to kind of add another service to make sure you can keep your promise. Sometimes another solution would be like, there is an authentication service like Auth0 that you can use. And they have an alternative that they say, well, we have our SaaS version, but we are also able to deploy our software on one of your services. So if one of our main service goes down, you will have like a local failover that you can do as well. So there's different ways of, like, you don't always have to pick another provider. You can maybe have the same provider, but apply it with different deployments, or maybe in another region or stuff like that. Okay. I think it was mentioned yesterday during one of the talks. So microservices, it lets you focus on one thing, but what I noticed when my team was doing it, it just added all the complexity on the deployment. So life became easier for them, but for me, okay, instead of deploying only one WAR file or something, I had to deploy like 20 services. So the complexity just came back to me. So you probably have to find a balance between the things and not go all the way and split everything up. And even with the functions, it's even more fragmented. And one by one, now I really almost need to know the code, how it works, and how the functions are to understand everything that needs to be done. So there's a trade-off in complexity when you start doing this. So it sounds a bit cheesy, but every promise is a relationship. And it's not just the working together from a documentation. What I do is always with my suppliers, I try to have almost like a personal contact that I can talk to. So sometimes you have multiple services, like storage, network, database, that are just grouped, again, as one agent. They're abstracted away for you, and that's what they call a super agent. So in the super agent, internally, they might have different services, again, that work together, but me as a user, I don't see it anymore. So they are a super agent, like Amazon database service. They probably have different parts working internally together, but I don't see it anymore, and I just see one node, which is the Amazon agent, but internally they're actually a super agent for definition. And like I mentioned before, you need to have a choice with multiple super agents if you want to work together. It becomes also more complex if each of the different agents has versions, because I need to pick version 1 here, version 2 there, this has this functionality, but in the new version it hasn't. So if an agent promised me something, he has to make sure it works in all versions, or he has to clearly specify the conditions that in version 1 it was like this, in version 2 it was like that. And as the super agent internally grows, like in Amazon, it might take a long time for them to update something. So the bigger the super agent gets, you will kind of see hints from the outside. I don't know what's happening internally, but if they tell me it's going to take a month before we go to a new version, I know they're getting big insights. And maybe it's time to take a service somewhere else, because it just got too big and too slow if I want to keep up with new features, new industry stuff. This is typically where when the super agent becomes too big, there will be little smaller agents coming there with the one focused thing, and they will do a split off everything within the super agent. So it's important also under load, or when you scale, that you have the same promise. Remember the load balancer? They say, oh, it's no problem, but it was not really well specified that when you hit 10,000 requests per second, that you had to give them a call. So we had to find out later. Gonna skip that one. So, for a long time, I puzzled with the idea, because a lot of people say, well, once we've defined what the contract is for working together and we have an API, everything has been settled. We don't have to talk to each other. So if I use an external service, if they just have a good API and documentation, why should we collaborate? And it was always hard in my mind, is this the ultimate goal of DevOps, that we collaborate until we don't have to collaborate anymore? It just didn't fit in my mind. So yeah. And then I started understanding it is DevOps, how this works. But it's just different than what we are used to. We are not looking for the practices inside our company and have them work together, but we are thinking about working together in an ecosystem from one company to the other company. And I'll show you a few of the practices that I think that our people are starting to use. So a lot of companies have maybe they're monitoring internally, and you can see maybe already they exposed their Nagios page or something to internally, so people can say, the mail server is down, the web server is down, and so on. A lot of the companies are taking it a step further, and they will show the outside world what is happening in their inside world. And they just show, okay, the database service is up, this is down, so you can actually see me as an agent using the other agent. I don't have to call them, but I can see what's happening within their system. This is something Amazon learned the first time, then completely went down. Everybody was trying to call, and now with the simple status page, they could just say, okay, and after a while people know, I'll just check, is it down, is it up, oh, they're working on it, everything's okay. So a very simple thing. Some of the services are starting to expose not only their status, but also their metrics. I can see the delay, how long it took to push out a message. So I can see the variations, and even though the system is working correctly, I can see whether it's getting slow, faster, there's an issue, there's skew. So it's like we discussed, radiating information within your company is just radiating and putting all the information and showing it to the outside world. So this is an image service, and not a lot of people do that, but they actually show their internal error rate. So I can see, if I'm on a show, I can see what's happening over there. It's really important for me. So maybe I can fail over to another agent, or patch, or kind of shut down the service so it's not degraded. Another thing that people started to do is that you can subscribe to the updates. So think about when you change something in the system, the change log that you note, version 1, this happened, version 3. I can just subscribe and get an email every time there's a new update. So I get a summary, a description, so I'm getting a conversation with these companies from the outside. Sometimes it's really scary, and you get like, oh, system is down, system is up, and then you think, oh, maybe I need to switch provider, but at least they're being honest on the problems they are having. But the important for me is that I can see and make good decisions for the promises that I make. Fastly is a CDN. It doesn't keep the log files internally. It just says, well, where do you want your log files? We do a service. We create logs. Do you want to have them? Because maybe you can correlate them with logs of other services. So they allow you a way to kind of get their internal logs within your system. And then I don't have to explain the importance of error messages and error codes. It's hard to read. But do not like leak in your mobile application. There is a sharding error in the MongoDB. I don't think the user is very helpful for that. But when I see that as a system administrator, at least I have a clear view on all the error states my agent has expected to have. And from that I can already see, hey, he thought about this, he thought about that. So it always almost becomes like technology marketing. If I have to pick an agent, I will see how mature he is by how much he exposes to the outside. It's one of the things that always boggles me. Like a lot of people use a mail service like Gmail and stuff, and then I always ask them, do you have a backup? Oh, no. So it's still for you to create the backup. If somebody hacks into your account and deletes all your email, for some business it will just be a disaster. So even though you're using a service, there is still a job for you to create a backup. If you find it important enough, of course. But imagine losing all email contacts, all the offers you made, all the contacts, and so on. Okay. Now even more and more, and Slack is a good example, like the status page, if people are talking about the problem or the outage on Twitter, they just answer you. Yes, we're working on it. So there is a direct engagement. This is almost like the dialogue we talked about. That is another way of communicating. It's not just there's an API, there's a status page. No, they're actively doing this and say, oh yeah, we're working on it, good idea, all that stuff. So this is the new communication, in my opinion, that's happening. More and more, and it's a good thing, when there is a failure inside a company, they look at maybe root cause analysis, or they create a postmortem, like what caused it, what can we do better, but they start publishing it on their website. And I know it sounds strange because, I feel scared if he thinks I'm not like a very good supplier and we did a failure. But guess what? The important thing is that if you describe, and by describing it, you show you're knowledgeable, and you show how you're going to handle the next time this problem will happen, this is more valuable, because for me that tells me that agent, he's learning and he will improve, and I will not hit the same problem. If you only publish that internally, I have to guess, and I hope you're going to get better, but at least here I kind of see the steps you're going to take internally to get better. Once in a while I get these emails from Amazon saying that server could have a problem in the future. We detected some kind of strange things. Maybe the hardware is degrading. Maybe, you know, the disk isn't that fast. We are going to replace that within 2 weeks. So it's not only the reactive part, like we talked with the monitoring. This is proactive work, and they're just telling me, okay, get some time, take some time, and do the upgrade and switch machines. And like I said, even just creating the changelog, what changed? Because remember that build system that just changed the virtual machine. If I can just go to your website and say, oh, okay, it's clear. Changelog, today you did this, and now I know what to fix, instead of what happened. So it's really helping me as a communication to work better with the agent. A blog is the same thing. This is a way of communicating how high is your skill internally. Are you have good engineers? Because what becomes important if you think about the services is picking the right service. Because I don't know you yet, I have no contact with you, but I think you have a good service. But if I see people writing very deep technology and I can see that your engineers are good, I suspect you will do a good service. If I only see a marketing picture of 2 persons smiling, I will probably not pick your service. Talk at conferences, more and more companies are just doing that. It is just another way of communicating to the outside. I often meet people from the services I use, and they explain how they use it internally, and I can talk to them at the conference and say, hey, you know, we had this, oh yeah. So even though they might be in another country, I'm creating a relationship with these services. The other way is that documentation usually is very documentation. This example gives you an idea on how easy they make it for me to try it. So they're taking the extra step for me to, you know, we're going to describe how the whole call works, but if you can just copy and paste this, you can run it, and you get that. So they're actually communicating on how you should use that, giving me examples, how to do things. And usually when I start using one of those new services, the first thing I do after I signed up and tried it a little bit, I make a page with feedback. And I just said, you know, I had this wasn't clear to me, how about this? And from my experience, all these services love this. Because for them it is very hard to get good feedback. They would pay to get good feedback to do that. And I had it a couple of times that by doing that, internally, the company wanted to do that, but because I sent the mail, they could take this mail, go to their manager and say, hey, this guy, he explained what the problem is. You see, you should really do something about it. I had it, you know, within Amazon, I had it within Datadog, I had it with others. Like, if you explain your problem and why you think this is an improvement, they get ideas and they may start doing it. And even for random things, like there was no outage, but I just had a question. I shouted it out on Twitter, and it just started replying to me. So this is the new communication. And because it's in the open, somebody else can see it, and they can kind of maybe help them in the next problem. And I used to, you know, in the old days, you would kind of, no, I never did that. Never. A lot of people would look at LinkedIn for hiring somebody. What I always ask, can I see your blog? Can I see your GitHub? Can I see your code? Can I see the projects you've done? And that for me is way more important to see the attitude, because maybe I can see how he communicated on a mail system. Is he the right fit culturally? Does he have like a learning attitude? So for me, that's way more important than looking at all the certifications on LinkedIn, which he might have bought by buying all the questions somewhere on the website. Plead guilty. So yeah. Some of them even allow you to talk directly to the engineers. So you have a problem. There is a chat channel from that service, and you just go to that chat channel, and there's a few engineers of that company, and I can talk directly to them. I don't have to go through support ticket, marketing, whatever to ask them. I can go directly deep with the engineers. I'll make sure not to bother them with trivial questions, and I will first check if the system is down and not bother them, check the documentation. But, it also shows me their willingness to talk to me and not make it somewhere behind a wall that I can never give them feedback and get it bi-directional communication. Some even put their whole board of next features on the internet. And they say, please comment. What should be the next feature? Where should we work on? So this is the new collaboration. Things that used to happen just internally into the company are now just put all in the public. I'm not saying you will always succeed and get the feature you want, but at least you see the roadmap, you see what's happening, who's working on it, and how that continues. So for me, when initially we were talking dev and ops, it is just not only inside the company, but also outside the company. And the industry already has a name for it. This is like supplier management, but I guess the supplier management, because we have changed internally, working more faster and so on, the supply management just has to start adapting on how we collaborate with each other. And remember, it's promises, not contracts. Allowed to fail. I know it's scary, but just being honest to the customer, say that you went down, because what is the most important? How fast you get back up to your feet. And that he sees that you're getting back up your feet. You're committed to fixing the problem. Obviously, the first thing gives a certain pain, but the fact that he knows that you're working on it, you're improving, that's way more valuable. And obviously you try to keep that promise, so you learn, you get better, and you improve. So for me, I think if there's one next silo we want to bust, it's just all the external services outside our company. And I think I already showed you the 2 books. There's another video which I think is very good at understanding everything with the promise theory that Jeff has given. And these are a few of the other books that I think are very well worth reading. A couple of them were already mentioned, but Beyond Blame is specifically on postmortems, and Designing Delivery is rethinking the way we collaborate in a service economy. And I think that was it. Thank you. Any questions? No questions? You can find me later if you want. Okay.
You mentioned Amazon's page and their status page. Sometimes it's hard to get answers out of there. Can you talk a little bit about when a status page for a provider is more useful, when it's less useful? Like, what would you like to see on customer status?
Okay.
Customer-facing status?
Yeah. So Amazon, in my opinion, is a super agent, so it's quite big. So when they say the service isn't working, and they have like 1 million services with that one dot, it will almost always be green. So they're not telling you that much. So I'm not saying this is the best. They could go much deeper, but they don't want to expose the internals there. For example, Travis is doing a better job and saying, well, the builds for Linux are down, the builds for Mac OS X are down, so they're breaking it more down to specific parts of their service. Amazon is just so big that one dot, like every complaints, even though everybody on Twitter is saying, are you having an Amazon problem? You would look at the dot and it's still green. So, but everybody complains about it. So I don't think they do a good service that way, but I think there were, I give the example because they were one of the first that really hit that problem of everything was down and they're getting all the calls at the massive scale, and one of the things they learned is really put the status on. I don't know if that was an answer. Yeah. Other questions? Okay. Thank you very much.